Good morning, all of you. My name is Kanak Manjuri. I'm a PhD research scholar in Computer Science Department. I'm here to discuss about the topic GAN, that is Generative Adversarial Network. This topic is very trending nowadays, and many research works have been done and are being done currently on this topic. So let's discuss about it. These are the contents which I'm going to discuss in this video of mine. First of all, we'll discuss about supervised and unsupervised learning. Then we'll discuss about discriminative and generative model. Then we'll discuss about generative modeling, which includes autoencoder, variational autoencoder, GANs, the applications of GAN theory, its architecture, the cost function, and different types of GAN. Okay? So let's discuss about supervised and unsupervised learning. Supervised learning. Supervised learning, in this we use the label data. That means the data is labeled, that is classes are defined. And in unsupervised learning we use unlabeled data. Supervised learning are basically used for classification and regression, while unsupervised learning are used for clustering. Also, in supervised learning we use training dataset, and in unsupervised learning we just use input dataset. Okay? Now discuss about the discriminative model. Discriminative model is also called a conditional model. Discriminative model is used to discriminate between the original and fake content. Okay? In this we find the probability y upon x. That means we find the conditional probability of y depending upon the probability of x. It is used in statistical classification in supervised machine learning. Its example is logistic regression, conditional random fields, and etc. Okay? Next is generative models. The generative models, the main aim of it is to learn the set, the data, and to generate new data. Okay? So that means it first learns the distribution, it first learns the input training data, and then after getting the training, it generates the new data which is similar to those training data. Example are Naive Bayes, Hidden Markov, GAN. Okay? Now, we have x, that is x is input data points, and if we want to classify y, so for generative model, we'll find the joint probability, that is p, x, comma, y, and for discriminative model, we'll find the conditional probability, that is p, y upon x. Through discriminative model, we find the boundary between two classes, while through generative model, we classify two classes. So here you can see the difference between the goal of discriminative model is to estimate p, y upon x, and the goal of generative model is to estimate p, x upon y, and then to deduce p, y upon x. Through discriminative model, we learn the decision boundary, and through generative model, we learn the probability distribution of data. You can see in discriminative model, there is a boundary between two classes, while in generative model, we see the distribution of both the two classes. Okay? Now, unsupervised learning are divided into non-probabilistic and probabilistic model. Probabilistic means generative model. GAN is a type of probabilistic model, which we will discuss in next slide. Generation. It is a kind of unsupervised approach. In this, we require large amount of data, like we use epochs of 50,000 and more than that. Okay, and we can generate any type of data. It can be image, it can be audio, it can be video, music, anything. Suppose we have few poems and we want to generate new poems similar to those poems, we can do it through generating techniques. Okay, now what is autoencoder? Autoencoder basically has three layers: input layer, output layer, and hidden layer. Okay, as we have discussed, it has three layers, right? The basic aim of autoencoder is to reconstruct the input image from the output image. So here, through encoder, the input image is compressed and compressed images represented, and for again reconstructing the input image, it is again passed to the decoder to reconstruct the input image. So main aim of autoencoder is dimensionality reduction. Now what is difference between autoencoder and a variational autoencoder? Variational autoencoder is a type of autoencoder, right? Autoencoder is a compressed representation by first compressing the input image and then again decompressing it, right? It is aided by using some distance function which quantifies the information loss. In variational autoencoder, Along with the input image, an additional constraint is passed to the encoder network, which forces to generate latent vector, which roughly follows Gaussian distribution. This is the main difference between the general autoencoder and a variational autoencoder. Now, what are the various application areas of GAN? Various application areas of GAN. Suppose if we have if we have text and we want to translate text into images. So for that we'll use GAN. If we have few images, if you want to generate new images, so for that we'll use GAN. If you want to generate short videos and advertisements, we'll use GAN. For image retrieval, drug discovery, molecule development, in these application areas we can use GAN. This is the example. First image is the original image, and the last image is the image generated from generative adversarial network. It is not exactly the same image, but it is similar to the input image, right? This is the main GAN architecture. There is two network, generative network and discriminator network. Okay, discriminator network has two input, real image and fake image. Fake image is generated through a generator network, and the discriminator network distinguishes between real image and fake image. This is the basic functioning flow of GAN. And being more technical, we can see we have real world images. We take a sample X from the real world image, and parallelly we have some noise Z which is passed through a generator, and a sample and few images with noise is generated, which is similar to real world images, and a sample of that image GZ is taken. Now X and GZ, that means sample of real world images and a sample of generated images, both are passed to the discriminator. And now discriminator, the task of discriminator is to distinguish between the original image and generated image, that is real and fake image. So this is the basic architecture of GAN. Now, as we have discussed, both two processes are here shown parallelly. We have an original image, right? X sample is taken, it is passed through the differentiable function, and here dx tries to be 1, that means the image is real. That's why the aim of discriminator is to make it 1, near to 1. And the second process is input noise Z, which is differentiable function passed to differentiable function G, and a sample is taken from that, which is it is passed to a discriminator. Now D, that is discriminator, tries to make DGZ to 0. That means discriminator's task is to detect the image which is from the generator, that means which is not real, but generator tries to make DGZ near to 1. That means the generator will constantly try to prove that the image it has generated is real, while the discriminator will try to learn whether it's actually real or not. Okay. Now the theory of GAN, as we have already discussed, the generator module and discriminator module both are complement of each other. A generator module which learns the data distribution, okay, and then it produces the similar data which is not exactly same, but which has a quite variations with the original data, and it generates those data. So it's like a min-max game between discriminator and generator. Like generator will constantly try to generate new images, fake images, and discriminator will constantly try to detect what image is original, which is coming from the real world image, and what is the generated image. Now this is the mathematical equation for generator. As we can see, Z is a noise which is passed through a generator, and it is passed through a discriminator. So for m number of points, the log function is applied to the complement of that product we have obtained after passing it through the discriminator. So the job of generator is to generate first learn the distribution and generate the data which is similar to the data of original data, and then generate such kind of data so that discriminator is not able to discriminate between the original and the generated one, right? So discriminator needs to keep its level up to date with generator so that it is able to detect all the techniques the generator is using to generate the image or some data. This is a discriminator, that means it has both the input from the generator module and the input from the original data. So log is applied to the sample data which is passed through a discriminator module, plus the log of complement of the noisy data passed through the generator module and discriminator module for all m number of points. Okay. Now this is the cost function. So the GAN's objective is to solve the minimax problem. So the cost function, so we can find the separate of the original part, that is log of the original sample passed through discriminator module plus the log of complement of the noisy data passed through generator module and then passed to the discriminator module. Now, what's the difference between GAN and autoencoder? As we have discussed, GAN's aim is to produce the data which is similar to that of original one, and then again discriminate between the original and the fake one, while the aim of autoencoder is dimensionality reduction. If we have a large size image and if we want to reduce the size, so this can be done through autoencoder. Through GAN, we do not produce the similar image as that of input image, but we produce images which is almost similar, which has quite variations with the input image, while the aim of autoencoder is to produce the similar input image which is 100% similar to that of input image. So this is the basic difference between GAN and autoencoder. Now these are different types of GAN's architecture. First is normal GAN, second one is conditional GAN. In conditional GAN, an additional constraint is passed to the network. Third one is entropy based GAN. Fourth one is auxiliary conditional GAN, and fifth one is info GAN. There are many other types of GAN which are there. So I guess this video of mine is useful for you, and please keep on watching my video. Thank you.